Good morning, students. Welcome back to Physics Division class. Right. So in the last class, we stopped in part C. So both postulate mugitu, right? So move on to the next question. That is 36th question. Experimental observations of photoelectric effect. Right. Question number 36. Right. So experimental observation. So the first experimental observation is photoelectric effect is instantaneous. Photoelectric effect is instantaneous process. Right. So that means spontaneous agi electrons enagutte metal surface inda emit agutte. So that one is the first observation from the photoelectric experiment, right? So the second one is for every photosensitive material there should be a minimum frequency. We call that as the threshold frequency, right? So below the threshold frequency there will be no photo emission, right? So that is the second observation, right? For every material there should be minimum frequency. So we call that one as the threshold frequency, right? So prati one material ku adride ಆದ frequency irutte. So minimum frequency anta minimum frequency na ನಾವು threshold frequency anta ಕರೀತೀವಿ, right? So below which there is no photo emission. So ಆ threshold frequency ಗಿಂತ lesser frequency ಯಾವುದಾದ್ರೂ ಒಂದು ಮೆಟೀರಿಯಲ್ ಮೆಟಲ್ ಪ್ಲೇಟ್ ಮೇಲೆ ಇನ್ಸಿಡೆಂಟ್ ಆಯ್ತು ಅಂತ ಹೇಳಿದ್ರೆ ಸೊ ಅದರಿಂದ ನಮಗೆ ಏನು ಲಿಬರೇಟ್ ಆಗಲ್ಲ, ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಲಿಬರೇಟ್ ಆಗೋದಿಲ್ಲ, ರೈಟ್? ಸೊ ದಟ್ ಒನ್ ಇಸ್ ದ ಸೆಕೆಂಡ್ ಅಬ್ಸರ್ವೇಷನ್. ಸೊ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಒಂದು ಮೆಟಲ್ ಸರ್ಫೇಸ್ ಇಂದ ಲಿಬರೇಟ್ ಆಗಬೇಕು ಅಥವಾ ಎಮಿಟ್ ಆಗಬೇಕು ಅಂದ್ರೆ there should be a frequency. That frequency should be greater than threshold frequency. So threshold frequency ಗಿಂತ ಜಾಸ್ತಿ frequency light incident ಆಯ್ತು ಅಂದ್ರೆ then only there will be a photo emission. That means electron emit ಆಗುತ್ತೆ, right? So that one is the second observation, right? So the third one is the frequency for which the above threshold frequency, right? So above threshold frequency photoelectric current is directly proportional to the intensity, right? So that is the third observation, right? So the third observation is for a frequency above threshold frequency photoelectric current is directly proportional to intensity of incident light, right? So that is the third observation. So previous ಹೇಳ್ತಿದ್ದ threshold frequency ಗಿಂತ ಕಡಿಮೆ ಇತ್ತು ಅಂತ ಹೇಳಿದ್ರೆ photo electrons emit ಆಗೋದಿಲ್ಲ. So threshold frequency ಗಿಂತ greater frequency, that is above the threshold frequency, that is the frequency which is more than threshold frequency, then the electrons are emitted. So electrons emit ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ so electrons are moving with respect to time, so that we call as the current. So ಇಲ್ಲಿ photons emit ಆಗ್ತಿರೋದ್ರಿಂದ ಅದನ್ನ ನಾವು photoelectric current. So this electric current is directly proportional to the intensity of the incident light or incident radiation. So for this we can plot the curve, right? So you can now plot ಮಾಡಿದ್ರೆ photo current is along the y-axis and the intensity is along the x-axis, right? So the curve will be linear that pass through the origin, right? So intensity 0 itandre there will be no emission of the electrons. That means photocurrent ಏನು ಇರುತ್ತೆ ನಮಗೆ 0 ಇರುತ್ತೆ, right? So from this These 2 points will be based on the threshold frequency. So threshold frequency ಕಮ್ಮಿ ಇತ್ತು ಅಂದ್ರೆ photo electrons emit ಆಗಲ್ಲ. So threshold frequency ಜಾಸ್ತಿ ಇತ್ತು ಅಂದ್ರೆ photo current is directly proportional to the intensity. So photo current means the emitted electron starts to move with respect to time. So electrons are moving nothing but they gains the kinetic energy. So that is the next observation, right? So in case of 3 marks if given that 3 points enough. So in case 5 marks if given that you need to write the statement with the graph, right? So explain ಮಾಡಬೇಕು. So explain ಅಂದ್ರೆ ಇಲ್ಲಿ graph represent ಮಾಡಿದ್ರೆ that's enough. So you need to write minimum 4 points for 5 marks. So 5 marks ಹೇಳಿದ್ದಾರೆ ಅಂದ್ರೆ minimum you need to write the 4 points. So the next point is the maximum kinetic energy of the emitted photoelectron, right? So the maximum kinetic energy of the emitted electron increase with the frequency. Increase with the frequency of incident light, right? So in electrons emit ಆಗ್ತದೆ, so emit ಆಗಿದೆ ಅಂದ್ರೆ those are moving. So those are moving is nothing but against the kinetic energy. So maximum kinetic energy of the photoelectron increases with frequency, that is increases with the frequency. So frequency increase ಆದಾಗೆಲ್ಲ kinetic energy ಕೂಡ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, increase ಆಗ್ತಾ ಹೋಗುತ್ತೆ, and it is independent of intensity of the light, and it is independent of intensity of incident light. So incident light ಮೇಲೆ ಯಾವುದೇ ತರದ್ದು ಡಿಪೆಂಡ್ ಆಗಿರಲ್ಲ, right? So the maximum kinetic energy of the emitted photoelectron increases with the frequency of the incident radiation. So frequency increase ಆಗ್ತಾ ಹೋದಾಗೆಲ್ಲ kinetic energy ಕೂಡ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, increase ಆಗ್ತಾ ಹೋಗುತ್ತೆ, and it is independent, right? So again if you plot the curve for the photo current, right, along y-axis and frequency along x-axis. So this is the curve with respect to photo current and intensity, and here is the curve for the photo current and the frequency. So frequency alli ನಾವು threshold frequency na mention ಮಾಡ್ಕೊಂತೀವಿ. So below the threshold frequency there will be no photo emission. So ಅಲ್ಲಿ photo current ಏನಿರುತ್ತೆ ನಮಗೆ ಯಾವಾಗಲೂ 0 ಇರುತ್ತೆ below the threshold frequency. So above the threshold frequency the curve we are getting the linear. So frequency increase ಆಗ್ತಾ ಹೋದಾಗೆಲ್ಲ kinetic energy ಕೂಡ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, electrons increase ಆಗ್ತಾ ಹೋಗುತ್ತೆ. So hence we are getting the current linearly. So ಅಲ್ಲಿ ಏನು ಬಂದಿತ್ತು ಅದೇ ತರನೇ ಕರ್ವ್ ಬರುತ್ತೆ, right? So here we take f naught or nu naught. So in frequency nu na represent ಮಾಡ್ಕೊಳ್ಳೋದ್ರಿಂದ nu naught. So nu naught is the threshold frequency, right? So below the threshold frequency ಈ region ಅಲ್ಲಿ there will be no photo emission. So ಇಲ್ಲಿ ಯಾವುದೇ ತರದ್ದು there will be no photo emission, right? So these are the experimental observations of the photoelectric effect, right? So next, move on to the next question, 37th question. What are optoelectronic devices, right? So what are optoelectronic devices? Name any two optoelectronic devices, right? So opto nothing but the light. So these are the devices which uses the phenomenon of both optics and electronics, right? So optics ಮತ್ತೆ electronics ಎರಡರದ್ದು phenomena ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ಯಾವ ಡಿವೈಸಸ್ ವರ್ಕ್ ಆಗುತ್ತೆ, ಸೊ ಅದನ್ನೆಲ್ಲದನ್ನು ನಾವೇನಂತ ಕರಿತೀವಿ, optoelectronic devices ಅಂತ ಕರೀತೀವಿ. So name two optoelectronic devices ಅಂದ್ರೆ we have three in our syllabus, that is LED, light emitting diode, then photodiode, then solar cell. So these are the three devices, that is the optoelectronic devices. So ಇದು ಕೂಡ ಮೊನ್ನೆ ಸಪ್ಲಿಮೆಂಟರಿ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಕೇಳಿದ್ದಾರೆ, right? So ಮೊನ್ನೆ ಕೇಳಿದ್ರು ಕೂಡ ಯಾವ ಪ್ರಾಪರ್ ಡೆಫಿನೇಷನ್ ಬರ್ದಿಲ್ಲ ನಾವು ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಡಿವೈಸಸ್ಗೆ. The devices which are based on phenomena of optics and electronics. So these are called as optoelectronic devices. So naming the field is light emitting diode, bracket LED, and photodiode, and the last one is solar cells. Right. So these are the optoelectronic devices. Right. So move on to the next question. Give the three differences between N-type and P-type semiconductor. Right. So these are the types of semiconductor. So differences is that 38 first one. So ತುಂಬಾ topics syllabus ಇಂದ remove ಮಾಡಿರೋದ್ರಿಂದ ಇದು ತುಂಬಾ important ಆಗುತ್ತೆ differences. Right. So first N-type semiconductor, another is P-type semiconductor. Right. So the first point is, so N-type semiconductor or the semiconductor which are formed by doping the germanium. So germanium is doping with the pentavalent impurities. Right. So these are formed by doping the germanium with pentavalent impurities. Right. So N-type only pentavalent impurities. So here in P-type, these are formed by doping germanium with trivalent impurities. So ಇದರಲ್ಲಿ valence electrons 5 ಇರುತ್ತೆ. So ಇದರಲ್ಲಿ valence electrons 3 ಇರುತ್ತೆ. So hence it is trivalent. So hence this is the right. So majority charge carriers or electrons. So electrons ಏನಿದೆ majority charge carriers ಇರುತ್ತೆ. So ಇದರಲ್ಲಿ holes are the majority charge carriers. Right. So next, third point. So here the mobile, that is charge carriers. So mobility of the charge carriers or the mobility of the majority charge carriers is high. Right. Mobility of the charge carriers is high. So here mobility of charge carriers is less. Right. So mobility of the charge carriers is less. Right. So one more point. So this one is donor impurity. So here is acceptor impurity. Right. So these are the differences between the P-type semiconductor and N-type semiconductor. So in that, again one more we have intrinsic semiconductor extrinsic semiconductor. So semiconductor ಅಲ್ಲಿ two types ಇದೆ. So intrinsic semiconductor ಮತ್ತೆ extrinsic semiconductor. So extrinsic semiconductor ಅಲ್ಲಿ again two types ಇದೆ. That is N type semiconductor and P type semiconductor. Right. So intrinsic semiconductor is nothing but, so these are the pure semiconductors. Right. So it is a semiconductor in, it is a semiconductor in pure form, right? So pure semiconductor na intrinsic semiconductor anta kariತೀವಿ, right? So it is a semiconductor, it is a semiconductor doped with impurity. So impurities na dope ಮಾಡಿರೋದ್ರಿಂದ ಅದನ್ನ extrinsic semiconductors ಅಂತ ಕರೀತೀವಿ, right? So here number of electrons and holes are same. So that means same number of electrons and holes which are present in the intrinsic semiconductor. So here equal. So number of electrons and holes are unequal. So ಇದರಲ್ಲಿ unequal ಅಲ್ಲಿ ಇರುತ್ತೆ, ಇದರಲ್ಲಿ equal ಅಲ್ಲಿ ಇರುತ್ತೆ. So next is conductivity depends on temperature. So here conductivity moderately depends on temperature. So ಅದರಲ್ಲಿ moderate ಆಗಿರುತ್ತೆ, ಇದರಲ್ಲಿ completely temperature ಮೇಲೆ depend ಆಗಿರುತ್ತೆ, right? So these are the differences between N type and P type and intrinsic and extrinsic. So intrinsic semiconductors are the pure semiconductor, extrinsic semiconductors are the semiconductors which are doped with the impurities. So again types of extrinsic semiconductor are N type semiconductor and P type semiconductor. So these are the extrinsic semiconductor doped with the pentavalent impurities. So that is P type semiconductor is also a type of the extrinsic semiconductor that is doped with the trivalent impurities, right? So move on to the next question. 39th question. Explain conduction band, valence band and energy gap in semiconductor. Right? So question number 39. So in the first one is valence band. Right? So what is valence band? The energy bands are completely filled. Right? Energy bands are completely filled at 0 Kelvin, right? So ನಮಗೆ energy levels ಇರುತ್ತೆ, right? So these are the energy levels. So ಇದನ್ನ ಏನಂತ ಕರೀತೀವಿ ನಾವು energy bands. So these energy bands are completely filled. So completely filled means, so each energy level is having the electrons. So electrons ಇರುತ್ತೆ, that is the valence electrons. So 0 Kelvin, all the energy levels having the electrons, right? So antaduna navenanta karitivi valence band anta karitivi, right? So the next one is conduction band. So energy band is above the valence band, right? So the energy band which is above the valence band, so that we call as the conduction band, right? ಸೊ ಎನರ್ಜಿ ಬ್ಯಾಂಡ್ ಎಂಬುದು ವೇಲೆನ್ಸ್ ಬ್ಯಾಂಡ್ is called conduction band. So this conduction band is either partially filled or it may be completely empty, right? So conduction band may be empty or partially filled. So the empty ನಾದ್ರೂ ಇರಬಹುದು ಅಥವಾ ಪಾರ್ಷಿಯಲ್ ಆಗಿ ಫಿಲ್ ಆಗಿರಬಹುದು, right? So if I write here so in this ಕೆಳಗಡೆ ಇರೋದು ಕಂಪ್ಲೀಟ್ ಆಗಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಫಿಲ್ ಆಗಿದೆ. ಸೊ ಇದನ್ನ ನಾವೇನಂತ ಕರಿತೀವಿ ಅಂದ್ರೆ this becomes the valence band. So ಇಲ್ಲಿ ಮೇಲ್ಗಡೆ ಇರೋದನ್ನ conduction band, right? So ಇಲ್ಲಿ ಯಾವುದೇ ತರಹದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಏನಾಗಿಲ್ಲ, ಫಿಲ್ ಆಗಿಲ್ಲ, right? So the next is valence band, conduction band, and the third one is the energy gap. So there is a gap between the valence band and conduction band. So valence band ಮತ್ತು conduction band ಅಲ್ಲಿ mid gap ಇರುತ್ತೆ. So ಅದನ್ನ ನಾವೇನಂತ ಕರಿತೀವಿ, energy gap, right? So the gap between valence band and conduction band. So that we call as the energy gap, and it is denoted by Eg. So Eg is the energy gap, right? So this is about the valence band, conduction band, and the energy gap, right? So based on this band theory, so band theory explain band theory anta kelbodu athwa explain single agi valence band, conduction band, energy gap antanaದ್ರು kelbodu. So in turn normal agi explain band theory anta kelidre, so you need to mention the valence band, conduction band, and energy gap, right? So based on the band theory we are going to differentiate the conductors and insulators and also the semiconductors, right? So that is the next question. Distinguish between the conductors, semiconductors on the basis of band theory. So ಅದರ ಜೊತೆಗೆ insulators ಅಂತ ಕೂಡ ಆಡ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಸೊ ಮೂರನ್ನು ಒಂದರಲ್ಲೇ ಸ್ಟಡಿ ಮಾಡಬೇಕು. ಸೊ ಇದು ನೆನಪಿರಬೇಕು. ಸೊ ಕಂಡಕ್ಷನ್ ಬ್ಯಾಂಡ್ ಅಂದ್ರೆ ಅಲ್ಲಿ ವೇಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರೋದಿಲ್ಲ. ವೇಲೆನ್ಸ್ ಬ್ಯಾಂಡ್ ಅಂದ್ರೆ ಕಂಪ್ಲೀಟ್ಲಿ ಫಿಲ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಸೊ ಆ ಬ್ಯಾಂಡ್ ಅಲ್ಲಿ ಕಂಪ್ಲೀಟ್ ಆಗಿ ಫಿಲ್ ಆಗಿರುತ್ತೆ, ರೈಟ್? So question number 40. So in that one side conductor, insulator, semiconductor, right? So the first point is there is no gap between the conduction band and the valence band, right? So in some conductors, right, so there is no gap between valence band and conduction band, right? So if you draw here, right, so ಇದನ್ನು ಬಾಕ್ಸ್ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ಕೊಂಡ್ರೆ ನಿಮ್ಗೆ ಈಸಿಯಾಗಿ ಗೊತ್ತಾಗುತ್ತೆ, ರೈಟ್? ಸೊ ಬುಕ್ಸ್ ಅಲ್ಲಿ ಕೆಲವು ಬುಕ್ಸ್ ಅಲ್ಲೆಲ್ಲ ನಿಮಗೆ ಬಾಕ್ಸ್ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಿ ಡಿಫ್ರೆಂಟ್ ಶೇಪ್ಸ್ ನ ಮೆನ್ಷನ್ ಮಾಡಿದ್ದಾರೆ, ರೈಟ್? ಸೊ ಬ್ಲೂ ಕಲರ್ ಇರೋದು ವೇಲೆನ್ಸ್ ಬ್ಯಾಂಡ್, ಸೊ ಬ್ಲಾಕ್ ಕಲರ್ ಅಲ್ಲಿ ಇರೋದು ಕಂಡಕ್ಷನ್ ಬ್ಯಾಂಡ್. ಸೊ ಅದನ್ನ ಶಾರ್ಟ್ ಫಾರ್ಮ್ ಆಗಿ BB ಮತ್ತೆ CB. ಸೊ ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ there is no gap between the valence band and conduction band. So in some conductors, the valence band conduction band is overlaps with the valence band, right? So the singularly explain conductor in band theory and the ಕೇಳಿದ್ರೆ ಅದನ್ನು ಕೂಡ ಮೆನ್ಷನ್ ಮಾಡಬಹುದು, right? So in some conductors there is no gap between the valence band and to the conduction band, and also in some conductors the conduction band is overlapped with the valence band, right? So insulator, so insulator ಅಲ್ಲಿ there is a large gap between the valence band and conduction band. So this is the valence band, right? So this is the conduction. So there is a gap. So energy gap here, right? So that is Eg, right? So in in insulators there is a gap between the valence band and conduction band. So compare ಮಾಡಿದ್ರೆ conductor compare ಮಾಡಿದ್ರೆ there is no gap between the condense band and valence band. So conduction band ಮತ್ತು valence band ಎರಡಕ್ಕೂ gap ಇಲ್ಲ. So ಇಲ್ಲಿ ಎರಡಕ್ಕೂ gap ಇದೆ, right? So next point, that is in semiconductor, right? So here there is a small gap between valence band and conduction band. So ಅದನ್ನ VB ಮತ್ತೆ CB ಅಂತಾನೆ represent ಮಾಡಬಹುದು. So here so valence band, this is the conduction band, right? So small finite gap will be there between the valence band and conduction band. So ಇದಕ್ಕೆ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಇಲ್ಲಿ ಗ್ಯಾಪ್ ಏನಿರುತ್ತೆ ತುಂಬಾ ಕಡಿಮೆ ಇರುತ್ತೆ. So that gap we call as the energy gap. So ಈ ಗ್ಯಾಪ್ ಅನ್ನು ನಾವು ಏನಂತ ಕರೀತೀವಿ? Energy gap ಕರೀತೀವಿ. That is Eg, right? So this is the first difference. So first difference ಏನು ಅಂದ್ರೆ there will be a no gap between the conduction band and valence band. So there will be a large gap between the valence band and conduction band. So semiconductors ಅಲ್ಲಿ there will be a finite gap between the conduction band and valence band. So finite small gap, ತುಂಬಾ ಚಿಕ್ಕದಾಗಿರುತ್ತೆ, right? So the second point, in conductor Eg is equals to 0. That means energy gap between the valence band and conduction band ಏನಿರುತ್ತೆ ನಮಗೆ 0 ಇರುತ್ತೆ. So here in insulator the energy gap Eg is greater than 3 electron volt, right? So energy na mention ಮಾಡ್ತಾ ಇರೋದು electron volt ಅಲ್ಲಿ. So Eg value ಏನಿರುತ್ತೆ, it is greater than 3 electron volt, right? So here in semiconductor Eg is less than 3 electron volt, right? So semiconductor the energy gap is less compared to that of the insulator, right? So on the third point, electrons in the valence band easily move to the conduction band, right? So this is the third part. So third point is that so valence band is nothing but the electrons which are completely filled in this energy band. So ಈ energy band ಅಲ್ಲಿ electrons ಏನಿರುತ್ತೆ ನಮಗೆ ಕಂಪ್ಲೀಟ್ ಆಗಿ fill ಆಗಿರುತ್ತೆ. So here the electrons are present, right? So conduction band means there will be no electrons which are present in the conduction band. So conduction band ಅಲ್ಲಿ ಕೆಲವು electrons ಇರಬಹುದು ಅಥವಾ ಇಲ್ಲದಲೇನೂ ಇರಬಹುದು, right? So as there will be a no energy gap between the conduction band and valence band, so even at low temperature, so even at room temperature also, the electrons starts to move from conduction band to valence band. So easy again of the electrons, it will start to move from valence band to conduction band, right? So that is the second property. Third point, right? So that we will be observed in the insulator, right? So electrons cannot move from valence band to conduction band, right? So electrons ಏನಾಗೋದಿಲ್ಲ valence band ಇಂದ conduction band ಗೆ ಮೂವ್ ಆಗೋದಿಲ್ಲ. Why? Because there will be a large energy gap. So energy gap ತುಂಬಾ ಇರೋದ್ರಿಂದ electrons cannot move from valence band to conduction band. So ಇಲ್ಲಿರೋ electrons valence band ಅಲ್ಲೇ ಇರುತ್ತೆ. So conduction band ಅಲ್ಲಿ ಕೆಲವು electrons free ಇರುತ್ತೆ ಅಥವಾ completely empty irutte, right? So there will be a no movement of the electrons from the valence band to conduction band, right? So here also electrons will from valence band to conduction band with increase in temperature, right? So semiconductor ಅಲ್ಲಿ temperature increase ಆಗ್ತಾ ಹೋಯಿತು ಅಂದಾಗ so ಇಲ್ಲಿ energy gap ತುಂಬಾ ಚಿಕ್ಕದಿರುತ್ತೆ, so hence the electron starts to move from valence band to conduction band. So valence band ಇಂದ conduction band ಗೆ electrons move ಆಗಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ when with increase in temperature. So temperature increase ಆದ್ರೆ ಮಾತ್ರ electrons ಏನಾಗುತ್ತೆ move ಆಗೋದಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ, right? So here the electrons are easily moved from valence band to conduction band, hence conductivity is high, right? So conductivity ಏನಿರುತ್ತೆ ನಮಗೆ ತುಂಬಾ ಜಾಸ್ತಿ ಇರುತ್ತೆ. So that value is, so that is equals to 10 to the power of 2 Simon per meter to 10 to the power 8 Simon per meter, right? So ಇದನ್ನ ನೀವು resistivity ಅನ್ನು ಬರೆಯಬಹುದು. So you can choose any one. So ಇಲ್ಲಿ conductivity ಜಾಸ್ತಿ ಇದೆ ಅಂದ್ರೆ conductivity is the reciprocal of the resistivity. So conductivity ಜಾಸ್ತಿ ಇದೆ ಅಂದ್ರೆ resistivity ಏನಿರುತ್ತೆ less ಇರುತ್ತೆ. So ಅದನ್ನು ಕೂಡ ಒಂದು ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಮೆನ್ಷನ್ ಮಾಡಬಹುದು, right? Resistivity is less, right? So conductivity ಜಾಸ್ತಿ ಇದೆ ಅಂದ್ರೆ resistivity less ಇರುತ್ತೆ. So insulator ಅಲ್ಲಿ ಯಾವುದೇ ತರಹದ electrons flow ಆಗ್ತಾ ಇಲ್ಲ, so hence conductivity is less. So conductivity is less and that value is rho, that is equals to 10 to the power of minus 11 to 10 to the power of minus 19. 10 to the power of minus 11 Simon per meter to 10 to the power of minus 19 Simon per meter, right? So next, here conductivity is lies in between conductor and insulator. So it lies between the conductor and insulator, right? So here rho is equals to 10 to the power of 5 Simon per meter to 10 to the power of minus 6 Simon per meter, right? So ಇಲ್ಲಿ ಕೂಡ one more point. So conductivity less ಇದೆ ಅಂದ್ರೆ resistivity is more, right? So same as here, resistivity lies in between conductor and insulator, right? So these are the few points based on the band theory. So band theory ಮೇಲೆ differences between the conductors and insulators are ಕೇಳಬಹುದು. Insulators ಅಥವಾ semiconductors ಅಥವಾ conductors and insulators based on band theory ಅಂದ್ರೆ ಅಲ್ಲಿ ನಮಗೆ band theory ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ಕೊಳ್ತಾ ಇರೋದು, right? right? So band theory diagram ಬರೋದು. So main important, these are the points. So ಅಥವಾ only explain the conductor based on the band theory ಅಂದ್ರೆ ಈ 5 points ಬರೋದು enough, right? So next 41th question, draw the logic gate and truth table of AND gate, OR gate, NAND and NOR gate. So ಮೊನ್ನೆ ಟೆಸ್ಟ್ ಅಲ್ಲಿ AND gate ಕೇಳಿದೆ, ಡಯಾಗ್ರಾಮ್ AND gate ಇದೆ, truth table OR gate ಇದೆ, right? So ತುಂಬಾ ಮಿಸ್ಟೇಕ್ಸ್ ಮಾಡಿದ್ರ, ಸೊ ಸಿಂಪಲ್ ಇದೆ. Right. 41st question, logic gate and truth table, right? So AND gate ke logic gate, so starts from AND gate, right? So AND gate, it has two inputs, two or more inputs and one output. So input A, B, right? So output na y anta consider ಮಾಡ್ತೀವಿ, y is equals to a dot b. So a dot b ಅಂದ್ರೆ multiplication, right? So and ಅಂದ್ರೆ multiply ಮಾಡ್ತಾ ಇದೀವಿ ಅಂತ. So and ಅಂದ್ರೆ addition ಅಲ್ಲ, ಇಲ್ಲಿ and ಅಂದ್ರೆ multiplication, right? So logic gate input a, b, y, that is equals to a dot b. So only two inputs ಇರೋದ್ರಿಂದ ನಮಗೆ four combinations ಬರುತ್ತೆ. So 0 0 0 1 1 0 1 1, right? So these are the four combinations. So multiplication is a normal algebra multiplication. So 1 into 0 ಅಥವಾ 0 into 1 ಏನಾಗುತ್ತೆ, so ಅದನ್ನೇ ನಾವು ಇಲ್ಲಿ ಬರೀಬೇಕು. So ಇದು ನಿಮಗೆ ನೆನಪಿತ್ತು ಅಂದ್ರೆ easily you can construct the truth table, right? So 0 into 0 0, so 0.1 again 0, so 1 into 0 0, so 1 into 1 1. That means so ಎರಡರಲ್ಲಿ ಯಾವುದಾದರೂ ಒಂದು ಇನ್ಪುಟ್ 0 ಇತ್ತು ಅಂದ್ರೆ ಫೈನಲ್ ಔಟ್ಪುಟ್ ಕೂಡ ನಮಗೆ 0 ಬರುತ್ತೆ. ಸೊ ಔಟ್ಪುಟ್ ಯಾವಾಗ ನಮಗೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ಬರುತ್ತೆ ಅಂದ್ರೆ ಎರಡು ಇನ್ಪುಟ್ ವ್ಯಾಲ್ಯೂ ಮ್ಯಾಕ್ಸಿಮಮ್ ಇದ್ರೆ ಮಾತ್ರ ಔಟ್ಪುಟ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಬರುತ್ತೆ. ಸೊ ಎರಡು ಇನ್ಪುಟ್ 1 ಇದ್ರೆ ಮಾತ್ರ ಔಟ್ಪುಟ್ 1 ಬರುತ್ತೆ, ರೈಟ್? ಸೊ ದಿಸ್ ಇಸ್ AND gate. ಸೊ ನೆಕ್ಸ್ಟ್ OR gate. ಸೊ OR gate ಅಲ್ಲಿ ಸೊ ಸ್ವಲ್ಪ ಬೆಂಡ್ ಆಗಿರುತ್ತೆ, ರೈಟ್? So here also it has two or more inputs. So here we take up only the two inputs and one output, y is equals to a plus b. So or irodinda alli plus add tara use ಮಾಡ್ಕೊಂತಾ ಇದೀವಿ. So again the truth table is, so ಇಲ್ಲಿ ಒಂದು level ಬರುತ್ತದೆ, right? So here it is a dot b, next y is equals to a plus b. So that means here it is AND gate. So here it is OR gate, right? So OR gate ಗೆ add ಮಾಡ್ತೀವಿ. So 0 plus 1 1 ಆಗುತ್ತೆ, 1 plus 0 1 ಆಗುತ್ತೆ, so 1 plus 1 1 ಆಗುತ್ತೆ, that is 1 0 ಆಗುತ್ತೆ, binary, right? So 0 0 0, so 0 1 1 1 0 1 1 1 1, right? So that is for the OR gate, right? So next NAND gate. So AND gate ಗೆ ಒಂದು ನಾಟ್ ನ ಆಡ್ ಮಾಡಿದ್ರೆ ಅಲ್ಲಿ ಏನು ಬರುತ್ತೆ ನಮಗೆ NAND gate ಬರುತ್ತೆ. So first we need to draw the AND gate. So it has two inputs, so A B. So ಇಲ್ಲಿ ಮುಂದೆ ಫ್ರಂಟ್ ಅಲ್ಲಿ ಒಂದು ಬಬಲ್, ಸೊ ಒಂದು ಸರ್ಕಲ್ ನ ಆಡ್ ಮಾಡಿದ್ರೆ ಅದೇನಾಗುತ್ತೆ ನಮಗೆ AND gate ಆಗುತ್ತೆ. ಸೊ ಒಂದು ನಾಟ್ ಗೇಟ್ ನ ಆಡ್ ಮಾಡಬೇಕು, ಸೊ ಅದನ್ನ ಡೈರೆಕ್ಟ್ ಆಗಿ ಇಲ್ಲಿ ಒಂದು ಬಬಲ್ ನ ಆಡ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ ನಮಗೆ ಅದು NAND gate ಆಗಿ ಬಿಹೇವ್ ಮಾಡುತ್ತೆ, right? So output y is equals to again a dot b. AND gate ಗೆ ಏನಿರುತ್ತೋ ಅದೇ ಇರುತ್ತೆ, ಬಟ್ ಇದೇನಿರುತ್ತೆ ಇನ್ವರ್ಟ್. So not gate is called as inverter. So ಇಲ್ಲಿ ಏನು ಮಾಡ್ತಾ ಇದೀವಿ ನಾವು ಇನ್ವರ್ಟ್ ಸಿಂಬಲ್ ನ ಯೂಸ್ ಮಾಡ್ತಾ ಇದೀವಿ. So again if we draw truth table, so y is equals to a dot b whole bar. So not gate ಅಂದ್ರೆ 0 ಇದ್ದಿದ್ದು 1 ಆಗುತ್ತೆ, 1 ಇದ್ದಿದ್ದು 0 ಆಗುತ್ತೆ. So ಇಲ್ಲಿ a dot b ಅಲ್ಲಿ 0 ಇದೆ, so ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ನಮಗೆ 1. So ಇಲ್ಲಿ 0 ಇದೆ 1, 0 ಇದೆ 1, so 1 ಇದೆ ಅಂದ್ರೆ 0, right? So next NOR gate, right? So NOR gate again OR gate. So OR gate ಗೆ ಒಂದು ನಾಟ್ ನ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ NOR ಆಗುತ್ತೆ. So that means we are adding one bubble in front of the NOR gate, right? So here also two inputs A B. So y is equals to a plus b, but ಇಲ್ಲಿ ಏನಿದೆ ನಾಟ್ ಯೂಸ್ ಮಾಡಿರೋದ್ರಿಂದ ಒಂದು ಇನ್ವರ್ಟರ್ ನ ಯೂಸ್ ಮಾಡ್ತಾರೆ, right? So here also y is equals to a plus b whole bar. So not get ಯೂಸ್ ಮಾಡಿರೋದ್ರಿಂದ AND gate ಗೆ ಔಟ್ಪುಟ್ OR gate ಗೆ ಏನು ಔಟ್ಪುಟ್ ಇರುತ್ತೋ ಅದನ್ನ ರಿವರ್ಸ್ ಆಗುತ್ತೆ. ಸೊ 0 ಇದ್ದಿದ್ದು 1 ಆಗುತ್ತೆ, 1 ಇದ್ದಿದ್ದು 0 ಆಗುತ್ತೆ, ಅಗೇನ್ 1 ಇದ್ದಿದ್ದು 0 ಆಗುತ್ತೆ, ಸೊ 1 ಇದ್ದಿದ್ದು 0 ಆಗುತ್ತೆ. So this is the whole truth table for the 4 logic gates, right? So this is NAND and this is for NOR. So these two are the inputs, right? So these two ಏನಾಗುತ್ತೆ ನಮಗೆ outputs. Right? So it is two logic table. So ಇದು ಒಂದು ಟೇಬಲ್ ನಾವು ಪ್ಲಾಟ್ ಮಾಡ್ಕೊಂಡ್ರೆ ನಿಮ್ಗೆ ಈಸಿಯಾಗಿ ರಿಮೆಂಬರ್ ಆಗುತ್ತೆ. ಸೊ AND ಪಕ್ಕದಲ್ಲೇ ನೀವು ಬೇಕಿದ್ರೆ NAND ಬರ್ಕೋಬಹುದು, right? So AND is inverter of the NAND and OR is the inverter of the NOR, right? So input ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ 0 0 0 1 1 0 1 1. ಸೊ ನೀವು ಯಾವ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಬರ್ಕೊಂಡಿರ್ತೀರೋ ಅದೇ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಇಲ್ಲಿ ಔಟ್ಪುಟ್ ಬರುತ್ತೆ. ಸೊ ಇದು ಮೇನ್ ಫಾರ್ಮ್, right? So 0 1, here it is 3, sorry, here it is 2 and this is 3, right? So the boolean ನಲ್ಲಿ ನಾವು ಬರ್ಕೊಂಡ್ರೆ ಸೊ ಬೈನರಿ ಡೆಸಿಮಲ್ಸ್ ಅಲ್ಲಿ ನಾವು ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ಕೊಂಡ್ರೆ ಇದ್ರ ವ್ಯಾಲ್ಯೂ 0 ಇರುತ್ತೆ, ಇದ್ರ ವ್ಯಾಲ್ಯೂ 1 ಇರುತ್ತೆ, ಇದ್ರ ವ್ಯಾಲ್ಯೂ 2 ಇರುತ್ತೆ, ಇದ್ರ ವ್ಯಾಲ್ಯೂ 3 ಇರುತ್ತೆ, right? So this is about the logic gates and truth tables. So diagram ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್. So AND ಮತ್ತೆ OR ಗೆ ಕನ್ಫ್ಯೂಸ್ ಆಗಬೇಡಿ, right? And the last one is define work function, threshold frequency, stopping potential. So work function 1 marks already banditu. So the minimum energy required to emit the electron from the metal surface, that we call as the work function. So minimum energy required agutte. So yavadallu one metal inda electron liberate athwa emit agbeku andre adanna navu enanta karitivi, aa energy na navu enanta karitivi work function anta karitivi, right? So next, the second one is the threshold frequency. So it is the frequency below which there will be a no photo emission. So threshold frequency is the minimum frequency. A minimum frequency idre matra enagutte namage electron emit agutte. So below the threshold frequency there will be a no photo emission, right? So and the last one is stopping potential. So it is the minimum negative potential required to stop the flow of electric current in the circuit, right? So negative potential, that means opposite potential na apply ಮಾಡ್ತಾ ಇದೀವಿ. So minimum potential which requires to stop the flow of photo current. So photo current flow ಆಗೋದನ್ನ ಸ್ಟಾಪ್ ಮಾಡೋದಕ್ಕೆ we are applying the potential. So ಆ potential ನ ಏನಂತ ಕರಿತೀವಿ, negative potential. So ಅದನ್ನ ನಾವು ಏನಂತ ಕರಿತೀವಿ, stopping potential, right? So these are the three definitions. So simple ಇದೆ, right? So ಇಲ್ಲಿಗೆ 3 marks complete ಆಯಿತು. So next class, so ನಾನು ಆಲ್ರೆಡಿ up to 5 questions ನಾನು previous exam ಮುಂದೆನೆ ರಿವೈಸ್ ಮಾಡಿದ್ದೆ. So once again I am revising because ತುಂಬಾ ಜನ ತುಂಬಾ ಮಿಸ್ಟೇಕ್ಸ್ ಮಾಡಿದ್ದೀರಾ ಡಿರೈವೇಷನ್ಸ್ ಅಲ್ಲಿ. ಸೊ ಪ್ರಾಪರ್ ಆಗಿ ಡಯಾಗ್ರಾಮ್ಸ್ ಬರ್ದಿಲ್ಲ, ಪ್ರಾಪರ್ ಆಗಿ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಇಲ್ಲ, ರೈಟ್? ಸೊ ಫ್ರಮ್ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ we start with the part D, right? Thank you.